Brown dwarf. Is it a star? Or is it a planet? Could red dwarfs be the last hope for humanity? Watch the video to know more. Let's start off with brown dwarfs. Judging by the name, we have the satisfaction of it being a star. But why does it being a planet come into the play? Before we proceed, let's understand their formation. Just like any other main sequence star, they are formed from clouds of dust and gas. Gravity piles the components in tightly and forms a young protostar at its center. Main sequence stars, gravity pushes inwards until hydrogen fusion starts. However, brown dwarfs never reach this stage. Before the temperature becomes hot enough for hydrogen fusion, the matter in them gets packed and it becomes stable, which leads to the formation of brown dwarfs. Stars are big balls of hot gas. There is more to it, but you get the point. Similarly, there are planets that are made up of just gases. These are known as gas giants, such as Jupiter or Saturn. Brown dwarfs emit very little energy in the form of light, so they can easily be confused with planets. Planets reflect the light of their stars, while brown dwarfs emit low light. Both have nearly the same luminosity when viewed from afar. Not just this, there are various factors that lead to their confusion. Brown dwarfs can have auroras, storms, and clouds on their surface. Of course, most planets possess these similarities. Brown dwarfs glow in the red and infrared spectrum until they sufficiently cool down, emitting X-rays and infrared light. Scientists measure these to know their details. But in order to measure these spectrums, they have to be within 100 light-years distance. Even so, the dividing line between a cool brown dwarf and a planet can be quite thin. Some brown dwarfs are cool enough to maintain atmospheres, much like gas giants. Let's consider a solar system, and the star of the system a brown dwarf. Also consider a planet revolving it. Now, nearby there is another planet that has a moon orbiting it. When we observe these two objects from Earth, let's say with a really powerful telescope, we won't be able to tell the difference between them. All these factors determine how hard it is to distinguish between a brown dwarf and a gas giant. They are mostly sized using Jupiter masses. They can range from 13 to 90 times the mass of Jupiter, or 1/10 the mass of the Sun. Their temperatures are very low. Some have the temperature similar to an oven, others so cool that they could resemble our body temperature. Inside their core, deuterium, which is just a single proton and a single neutron in a nucleus, can get joined by a stray proton, converting the deuterium into helium-3 and releasing a tiny bit of energy. Although all stars go through this phase and eventually move on, brown dwarfs continue deuterium fusion for their lifetime. As always, they exhaust all their energy and become a cold black dwarf. So are brown dwarfs really brown? Well, yes, but no. If you observe them from afar, they appear brown. As you get closer, you can see magenta hues surrounding the star. Although it almost classifies as a star, it still doesn't get a star's attention.